Morning, grade 8. Okay. Let's have now a continuation of our discussion for Science 8. All right. Okay. There's a question raised a while ago that science is hard. What makes it hard? Okay, some of you are under me last school year, okay? And you already know the catch. You already know how to study science, right? Apparently, a lot of you are not taking down notes, okay? That's a problem. It will become a problem. Why? Because I cannot supply you with those terminologies if you will not take down notes. Okay? I am not a typical teacher that spoon feeds my students. Huh? There's no spoon feeding here. How can you learn science? You take down notes. That's how we study science. Okay, no other way. Right? Let me share my screen. Can you see my shared screen now?
Yeah.
Yes.
Yes.
Okay, we actually stopped last meeting on this page. Okay. Scientists learn much about earthquakes and the interior of Earth by studying the propagation of seismic waves. Okay. Take note that seismic waves, okay, can be distinguished by the number of properties, including its speed, okay, the wave travels, and the direction the waves move, okay, as they pass by and where they actually do not propagate or do not pass. Okay, some of the waves will pass to solids. Some of the waves will eventually pass also in liquids. Okay. There are three main types of seismic waves. Please take note of the important terminologies there. Three main types of seismic waves. Okay. And they all move in different ways. Okay. These are the primary waves. Okay. P waves. Please take down notes. Please get your notebooks, science notebooks. Okay. These are P waves. Okay. Or primary waves, S waves or secondary waves, okay, and surface waves. Okay, each type of wave has a characteristic speed and manner of travel. Let's take a look at this one. Let's have P waves or primary waves. Okay, it is actually the fastest seismic wave and consequently the first to arrive at the seismic station before any other type of seismic wave arrive. Okay, the P wave can move through solid rocks or solid rock and fluids like water or liquid layers of earth. So it can actually travel through rocks, solid rocks, and it also can travel through what? Bodies of water. Okay, that's your primary wave or P wave. Okay, let's take a look at this. It pushes and pulls rock or rocks. It moves through just like the sound wave, push and pull the air. Okay. Again, P waves pushes and pull the rocks. Okay. It moves through or passes through just like sound waves, which push and pull also the air. Right? Have you ever heard about the big clap?
No.
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 Have you ever heard about the big clap of thunder and heard about windows rattling at the same time? When there is
Oh, I think so.
a big clap of thunder and the rattling of your windows, it means to say that it has actually what? If you heard thunder, okay, a big sound of thunder, okay, it follows what? It follows what? Since you heard, okay, since you heard a big clap of thunder, meaning to say that what? That sound, okay,
Created a big
travels.
impact and made.
Yes, Perfect,
The
Chavez.
windows
It
move.
created a big impact, which enables, again, your windows to rattle or sound, or to create a sound. Okay?
But the
The windows,
farther the impact goes, it slowly goes weaker until it disappears.
okay. So since it creates, okay, a rattling sound to your windows, it means to say that sound, okay, is a wave. It travels, okay, through a medium there, and it reaches your windows. Correct? Am I correct?
Yes, sir.
Yes.
Okay. The windows rattled because the sound waves were pushing and pulling on the window glass, much like P wave push and pull on rocks. Same as how your P waves also push and pull rocks. Okay, that's how P waves travel. Okay. Sometimes animals can hear P waves of an earthquake. Okay, dogs, for instance, commonly begin barking hysterically because before an earthquake hits, usually people can only feel the bump and the rattle of these waves. But dogs has a really sensitive hearing that they can actually feel the pushing and pulling of these waves. Okay, before an earthquake happens. The next kind or type of wave is the secondary wave or S wave. So what's with the S wave? Okay, S wave is the secondary wave you feel in an earthquake. Okay, an S wave is slower than your P wave and can only move through solid rock, not in liquid or gases. So it can just pass on or travel through solids, but not on liquid or gases. So if it reaches your oceans or bodies of water, it will just stop. As easy as that. It is the property of S waves that led seismologists to conclude that Earth's outer core is illiquid. Okay, because S waves do not travel through liquids. They are not always recorded at all locations during an earthquake. What happens then is S wave, and what happens to S wave is when they reach the liquid part of the Earth, here the S wave stops. Okay, again, S wave stops when it hits, okay, bodies of water or liquid. Okay, it can only travel through solids. Question so far? Grade 8?
No.
No.
Hopefully you're
Wait,
taking
wait.
down notes.
I have a question.
Make sure that you're taking down notes. Okay,
Sir, I have a question.
yes, Travis.
Why only water? Why can it only stop through water or gases?
Why only water? What do you mean?
Why does a secondary wave only stop when it hits water or gases?
Well, simply because S wave is shorter than the P wave. Okay, S waves also is um these are waves that come along after the primary wave. So meaning the energy there is much
Weaker.
slower, much lighter, what else? Much um less or lesser compared to the P wave. That's the reason behind. So it cannot penetrate
Okay.
on liquid. Okay, any other question
No.
aside from Travis' question? Okay, thank
No.
you for your question, Travis. I am encouraging everybody to ask question. I'll be happy or more than happy to know that you are asking question. What will happen if the weather is hard? What do you mean weather is hard? Huh? I cannot understand. Yeah, raining, you mean? MIA? Is this MIA? Am I correct?
Yes. Yes.
What do you mean raining? Oh, what? Oh, huh? We are under, again, we are under earthquake. We are not yet in typhoons. Okay. We are just illustrating how the wave move, how a wave travel. And we did differentiate the movements or the intensities of P waves or primary waves and S waves. we are illustrating now how they move. We're not talking about typhoons. We're not talking about raining. What if the rain is hard? What do you mean the rain is hard? Okay, let's take a look at this one. How would you connect rain and earthquake? Yes, definitely. You can't. Huh? Rain is liquid. And this is now the problem because you're mixing now different ideas. Rain is liquid. Yeah, but we are talking about earthquake. If there are some earthquake, the P waves or primary wave will just pass through solids and liquids. Okay, followed by the secondary wave. And the secondary wave cannot travel to liquids. That's the point there. We're not talking about rain. Okay, this is now the problem. Okay, do you know what? Let's take a look at this one. Okay, let's diagnose this one. The problem of this class is that you are mixing up ideas. Okay, we need to focus. We need to focus on a specific lesson. Okay, if you're gonna mix typhoon with earthquake or the movements of waves, it will just confuse you. It will make the lesson hard. Okay, because you're thinking a lot of things. We need to make it as simple as possible. I am making now as simple as possible. Okay? Diba I already given you a lot of examples like how P waves travel. So if you hear a thunder, dug in vernacular, okay, you can hear also the rattling of your windows. Diba? Or mulihok in your windows. Okay? So because your windows move or your jealousies move, tendency is there is something that makes it move.
Also, like, if you turn
That's
on a
what I
bass
meant.
boosted speaker on max volume, it will affect the other things and make them rattle or move.
Yeah, that's what I meant.
Just like
Because
my speaker.
I am illustrating the how a wave travels. That's a sound wave. But in earthquake, it's a different wave. It is called seismic waves. But they travel in the same way. They travel in a wave-like form or in a wave form. That's what I meant. So rain and typhoons are in different topic. We cannot mix them up. Sound waves, yes, correct. RJ. Okay, it looks like a sound wave. It travels like a sound wave. That's what I meant. Okay, we're still talking about primary wave and secondary waves. Yes, Travis, correct. Just like your speaker, if you put it on in a full volume, some of your things there will actually move. Because again, there is a sound wave and it travels like, again, your seismic waves. That's what I meant. Okay, do not mix those terminologies. Do not mix those ideas because it will actually make this lesson hard. That's the problem. Let's make this easy as possible. S wave move rock particles up and down, okay, or side to side perpendicular to the direction of the wave. It is actually traveling in. Okay, earthquake radiates P and S waves in all directions. Again, earthquakes or earthquake radiates P waves and S waves in all directions. An interaction of the P and S waves with Earth surface and shallow structures produce surface waves or L waves. Okay, please take down notes. Please take down the important terminologies there. Okay. Okay. L waves travel or arrive at the given point after the primary and secondary waves. Okay. What is L waves again, by the way? Or your surface waves? What is your surface waves again?
The interaction of P and S waves with Earth's surface and
Correct.
shallow structure.
Very good. It is an interaction. Okay. An interaction of P wave and S wave. Remember that they are moving simultaneously. They interact. Once they interact and reaches Earth's surface, it will produce surface waves or L waves. Okay. L waves travel from the focus directly upward to the epicenter. Remember the focus? Okay. Focus, or what are the other term of focus? Or the hypocenter. Remember the focus or the hypocenter? Okay. L waves travel from the focus or hypocenter going upward, up to the epicenter or the surface of the Earth. Okay. Then they move along with the Earth's surface the way waves travel in the ocean, just like the surface of the water rises and falls with each wave. So the Earth's surface moves up and down with each L wave that passes, up and down. Okay, L wave causes most damage during an earthquake because they bend and twist the Earth's surface up and down. Okay, that's the movement of the L waves. Okay, let's move now to the causes of earthquakes. Do you have any questions so far?
No.
Okay, let's move now to the causes of earthquakes. Okay, the Earth has four major layers. Okay, we have the inner core, the outer core, mantle, and crusts. Okay, preferably, okay, some of the books are actually linking this as three major layers because the inner core and the outer core, they created only one. So we have core, crust, mantle, and the core. Okay, the core is subdivided into two. We have inner core and outer core. Mantle also is subdivided into two. We have upper mantle and lower mantle. Okay, and the crusts is divided also into two. We have the upper crusts and the lower crusts. The lower crust is the brittle one. Brittle. When you say brittle, it is soft. Okay. The crust and the top of the mantle make up the thin skin on the surface of the planet. Okay, your biosphere. But this skin is not all in one piece, of course. It is made up of many pieces like a jigsaw puzzle that is covering the surface of the Earth. Not only that, but these puzzle pieces keep slowly moving around, okay? Sliding past one another and bumping each other. We call these puzzle pieces as tectonic plates, okay? Again, please take down the terminology, tectonic plates, okay? And the edges of these plates are called plate boundaries. Please take down notes. Okay, do you have any questions so far? With tectonic plates and plate boundaries, all right. The plate boundaries are made up of many faults. Okay, so your faults now lies on the plate boundaries. And most of the earthquakes around the world occur on these faults. Okay, since the edges of the plates are rough, they get stuck while the rest of the plates keeps moving. Finally, when the plate has moved far enough, the edges unstick on one of the folds and there is an earthquake. So if there is some slippage or unsticking of these edges, tendency is faulting happen, and of course it will be eventually followed by an earthquake because again there is a movement of plate tectonics. Okay, this is an illustration of your layers of the Earth. We have crusts, mantle, upper mantle, lower mantle, and your core. This is the inner core, and this is the inner core, and this is the outer core. Okay, while the edges of the folds are stuck together, the rest of the block is moving, okay, the energy would be normally cause the block to slide past one another is being stored up. Okay, when the force of the moving blocks finally overcomes the friction of the jagged edges of the fault and it unsticks again, all that stored up energy is released, making a huge
Earthquake.
earthquake. Yes. So here comes your earthquake. So again, earthquakes are the results. Earthquakes are the result of the movement of plate tectonics and faulting. Okay. The energy radiates outward, okay, from the fault in all directions in the form of seismic waves again. Okay. Waves like ripples in the pan. So when you ripple a pan, when you throw a stone in the pan, it ripples, okay? An up-down movement. So that is actually an illustration of a seismic wave. Seismic waves would actually look like that, okay? The seismic waves shake the earth as they move through it, and when they reaches or the wave reaches the earth's surface, they shake the ground and anything on it, like our houses or even us, okay? We can actually feel it, especially if you are in the high-rise building. You can actually feel the movement of Earth's shaking or the movement of the crusts. Intensity and magnitude. Let's take a look at intensity and magnitude. What are the difference between them and how can we identify the destruction, that possible destruction of that certain earthquake? Okay. The size of an earthquake depends on the size of the fault and the amount of slip on the fault, okay? But that's not something scientists can simply measure. We cannot simply measure the one, okay? With the measuring tape, since faults are many kilometers deep beneath the Earth's surface, we cannot just measure them, but rather we can do what? So how can we measure an earthquake? What are the ways on measuring the intensity or the magnitude of an earthquake? They use seismogram, okay, or seismogram, okay. Seismogram recordings made on the seismographs at the surface of the earth to determine how large the earthquake was, okay. It will determine how large the earthquake was. A short wiggly line that doesn't wiggle very much means the small earthquake, okay, and a long wiggly line that wiggles a lot means a large earthquake. That's how we measure the intensity or the magnitude of an earthquake. Okay. Yes, RJ, we will be talking about that later. Okay. We still have 9 minutes or 10 minutes more. Okay. The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of slip. So let's take a look at this one. What are the differences between intensity and magnitude? The size of the earth, okay, the size of the earthquake is called the size of the earthquake. It is called the magnitude. So you can actually observe that on reports with regards to earthquakes, okay, in news, they're talking about magnitude 7, magnitude 9, magnitude 6. There is one magnitude for each earthquake. Scientists also talk about the intensity of shaking an earthquake. And this varies depending on where you are during an earthquake. Okay, magnitude, okay, please take down, measures the energy release at the source of the earthquake. Again, magnitude measures the energy release at the source of the earthquake. That's the magnitude. Magnitude determined from the measurement on the seismographs. Okay, there is a device that is used to measure the magnitude, while intensity measures the strength of the shaking produced by the earthquake at certain location. Okay, intensity is determined from effects on people, human structures, and natural environment. Okay, again, magnitude, okay, measures the energy release at the source of the earthquake, meaning to say that they use a tool for this to measure the magnitude, the energy that this earthquake released. Okay, while intensity measures the strength of the shaking or the effect. It measures the effect, okay, of certain earthquake. Okay, measures the effect of certain location. It also measures the effect on people and in the natural environment. Even human structures like your buildings. So that is how we measure intensity. Do you have questions so far with magnitude and intensity?
No.
I wrote it
Let's
down,
move
so
forward.
no.
Let's move forward. Seismograms come in handy for locating earthquakes too. Okay, and able to see P wave and S wave is important. You learn that P and S waves each shake the ground in different ways as they travel through it. P waves are also faster than S waves because again, P waves reaches the ground first before S waves. Okay, and this fact will this fact is what allows us to tell where an earthquake was. So this is the way how we locate what the epicenter of an earthquake. Okay. To understand how this works, let's compare P wave and S wave to a lightning and thunder. Okay, this one. Light travels faster than the sound. So during thunderstorm, you will see first lightning and then you will hear thunder. Correct? You can see first a lightning, kilat, before dugdug. Okay, let's make it in vernacular. So why? Because light travels faster than the speed of sound. Okay? If you are close to the lightning, the thunder will boom right after the lightning. Okay? If you are far away from the lightning, you can actually count several seconds before you hear the thunder. Okay? The farther you are from the storm, the longer it will take between the lightning and thunder to occur, or between the lightning and thunder to be observed. Okay? Meaning to say that light travel faster than the speed of sound. So you can observe first lightning before thunder. So P wave is just like your lightning. And S wave is just like your thunder. So
Wait, so
because light travels faster, so you can observe lightning first before thunder. Yes, Travis?
uh so depending on where you are and how far you are from the source of the thunder, whatever, there will be several seconds of delay depending on where you are.
Yes, it depends
Okay.
on. Let's continue. So this is now the comparison. We can actually see P waves here. It reaches the ground first, while S wave is smaller. Okay, P waves is more concentrated. Have you seen the P wave? This is the P wave. This is more concentrated, meaning to say that it has a larger or it has a bigger force rather than S wave. Okay, P waves are like lightning and S waves are like thunder. That's what I had discussed a while ago. P wave travels faster and shake the ground where you are first, then followed by S waves, which shake the ground also. Now, if you are close to an earthquake, P and S wave will come right after the other. But if you are far away, there will be more time in between. Okay, more time in between the two. Okay, so P wave will actually what? Will actually move in the direction of, look at the P wave. What is the movement of P wave there? It
Like
is
more consistent.
moving what? What is the movement of P wave there? You look at the arrow. You look at the arrow there. What is the movement of P waves? Travis. What is the movement of the P wave there? Huh?
Straight.
Straight? Straight,
Yes.
look at the arrow.
It's like spreading.
It's compressed.
Yeah. Compressional and what? They compress
Not compressed.
and not compress.
They-
They compress and
Expand.
Opens and close.
okay, open and close. They
and-
compress, compressional and what is that movement? They're moving away
Upward.
and they compress. So that's the movement of P wave. Okay. While S wave is moving what? S wave is moving up and down direction. Okay. Creating shakes. Creating now destruction on land. Okay. I think we had discussed everything. Okay. This will come out in your major exam. And I am done making your major exam, your first periodical test. It is actually 60 items. All in all.
Is it mostly essays?
There are
And
some essays
identification.
there. There are some identification, yes.
Okay.
Do you have any questions so far with our discussed topic?
No.
Oh,
All right. I think we have discussed a lot. We still have 1 minute left. Right? If you don't have question, I think that will go for today class. Okay, please take note of the important terminologies there. Okay, you unlock those terminologies. You need to study those. Studying those is not memorization. I don't want memorization in my class. I want familiarization. You familiarize with the terminologies. Do not mix your topic with other topics because it will create confusion in your mind. And you will think that it is hard. It is not hard. You're the one making it hard. You are the one making it hard. We are taking our lessons little by little in order for you to understand further. Okay? Do not make it hard. Let's make it as easy as possible. I think that will go for today, class. Thank you for your participation. Grade 8. Have a nice day, everyone. Take care. Bye-bye.
bye.
Enjoy the rest of the day.